Very warm welcome to everyone who has joined us from across the globe. So, good evening, good afternoon, and good morning to everyone out there, and welcome the STEAM panel speaker with us. So, without delay, what I'll do, I'll quickly flash my screen. I'll set the context about the topic. So, today's topic is leveraging smart machine for the future of manufacturing, and quite interesting topic and need of the era where every industry is striving towards having digital transformation in the organization. Quickly, I would like to introduce the STEAM panel speaker with us. We have Mr. Jaivel Murugan, who comes with 40 plus year of experience in industry experience and having a versatile experience in process sector, steel, capital goods, manufacturing, and currently he is heading the business unit in L&T rubber processing machinery. Welcome, Mr. Murugan, to the sessions today. Over to you for a quick word.
Uh, Good evening, good afternoon, and good morning to everyone. It's a very interesting session. I'm looking for this lot of interaction with the team.
Thank you. So we have a second speaker with us, Mr. Chinmay Hardas, who comes with more than 2 decades of experience in industry, and out of that 15 plus year in the SAW system. He's supporting the manufacturing sector in digital transformation in the entire end-to-end supply chain. So we welcome you, Mr. Chinmay Hardas, in the today's session. Over to you for a quick word, please.
Thanks, Apoorv, for having me here. Again, thanks everyone for joining in. Looking forward to the session and sharing perspectives from a digital angle as well. While we're talking about smart machines, which is very much the forte of the actual plant, but how do you kind of in the virtual world simulate it and get value out of it is what I look forward to sharing and probably having some questions around that as well. Thanks, Apoorv.
Great, thank you. Thank you so much. So let me quickly give you a quick background about Frost Sullivan. We are a global growth transformation company. We are helping organizations across the globe in 40 plus countries from strategy formulation to implementation support in more than 20 plus sectors falling under these 9 industry verticals. That's a quick background about organization. Now, this slide is quite familiar with each and every person in the entire world. 17 sustainability development goals. Now, this has been mandated by United Nations to be adhered by all 195 countries, which is member of United Nations. And the nation and the country can only be adhering or achieving their sustainability development goals when the industry in those countries are adhering and achieving their SDGs. So I would like to take your attention on SDG number 9, industry innovation and infrastructure. That's where the innovative advanced technologies has to be adopted by the industry to take the transformation journey in the right direction. So connecting to this, we have identified these 8 strategic imperatives, those factors which affect the growth in the organization. So customer value chain compression, transformative mega trends, internal challenges, competitive intensity, geopolitical chaos, disruptive technologies, and so on and so forth. So these are the factors which is affecting the growth in the organization. And today's topic will be dwelling upon how we are taking care of the internal challenges by adopting the disruptive technologies in the organization and specifically in the manufacturing sector. So that's the context here, and that's how we would like to take it further. So I just thought to set the context now. Before, without further delay, I will quickly take this session ahead, and I would like to have few points to be posed on both the esteemed expert we have, and would like to hear from them about their perspective, how they are, transforming in their organization or digital transformation. So, would like to quickly take the first question to you, Mr. Jaivel. How do you foresee the integration of advanced technologies like AI, IoT, and big data shaping the future of smart factories? And what are the key steps of successful implementation you had adopted in your organization? If you can throw some light on this, please.
Yeah, it's right. The smart factory is a highly digitized and connected production facility that uses advanced technologies to automate and optimize manufacturing processes. The integration of AI, IoT, and big data is poised to redefine the landscape of smart factories, making them more intelligent, flexible, and efficient. How these are all helping us and what are the tools we are using? One is that, say, automation, the use of robotics and CNC machines to reduce manual work in our operations. That way, that automatically that this give that more intelligence and more smart factory, smart operations in our activity. No. Second thing on this using of artificial intelligent platform to analyze the data for predictive maintenance, enable autonomous decision making and real time process optimization. Third one is enhance quality control with machine vision and predictive analysis. It is supporting for the quality by seeing that taking the image of the good product and the defective products, automatically that the delivery of the product will come with a good quality product from the machine. No. Also that fourth point is that power intelligent robotics and adaptive manufacturing systems. So these are all the by AI platform we are using as a smart factory built up. And second one is that using that IoT concepts, no, Internet of Things, connecting the machine tools, products in a single and responsive ecosystem. I'll connect everything together as a one input and giving that output to this systems. No, allow the continuous and real-time monitoring of equipment and product lines. It facilitate the predictive maintenance and remote diagnostics. So it will avoid that the breakdown maintenance and the failures in future and give that more reality and give that reliability to the machine operations now. And fourth one is that about the big data. Nowadays, everywhere using the big data for this tool. Now the tool is for the things now. The large amount of data are analyzed to improve efficiency and reduce the waste. Aggregate vast data from the sensors and serve devices and systems for deeper insights. Drive operational efficiency through trend analysis and performance optimization and enable demand forecasting, supply chain optimization, and product personalizations. No. So by using this, what are the benefits we are going to get it now? One is that higher efficiency and productivity. Second is reduced downtime and errors. Third time on predictive maintenance resulting in the better machine optimization uptime. Fourth is improved product quality, reduced rejection and reworks, and finally that better resources and energy management. These are all the benefits we are obtaining from this now. So for example, if you how the smart factory will be looks now. For taking a manufacturing setup of a car manufacturing plant having the machines communicate their performance status automatically and orders has been placed on the spares and the production and adjust the production based on the demand and forecast. This is a typical example for the smart factory, how it is working now. So some of the key steps for the implementation of these things. One is that the clear vision and strategies to be defined by this management to these employees now. So it is aligning the smart factory goals with the overall business objectives and identify the key use like predictive maintenance, quality improvement, where we are going to put as a smart facility that has to be defined properly in the vision and the strategies. Second thing on the access the current infrastructure. We have to evaluate that current infrastructures like existing information technology and operating platforms. So whether the smart facilities will suit our current production system, that has to be defined properly. Identify the gaps in connectivity, hardware and data system that will help us to put that smart facility in the current facility. Start with the pilot projects. We cannot take a smart facility for the entire plant now. We have to take a small pilot project and where that small implement in the small scale and high impact initiatives to test technology integration now. So measures outcome and redefine approaches before scaling up. So before scaling up, we have to see that what is the pros and cons of this small pilot project. Based on that, we have to take it forward for the larger area now. Ensure the data integration. See, we are using currently with the current platform now. So if you go with the new system and that the current system and the new systems we align with that. So use that open standards and platforms to ensure device and systems can be communicate properly now. create a centralized data infrastructure, seamless data flow. So invest the scalable technology. So we have to see that how to invest and where to invest, how it is going to be helpful for the future. That has to be important to see that as a whenever you go for the investments now. Choose the modular. First of all, you have to choose the existing platform, how to use it for the existing and making use of this new things in our system now. Choose a modular and cloud-based solutions that can grow with our needs now. Prioritize flexible and upgradability no. So focus on the cyber security. That is more important now. Everywhere that implement is that the data security is very, very important nowadays. We should have that very good cyber security connection in the system now. Develop mainly on the human resource is very, very important for this kind of going forward now. So that train the employees and digital tools and the data integrity and human machine collaboration, that is more important for the successful implementation of the smart factories now. Encourage a culture of innovation and continuous learning. This is more important, and to train the people to adopt the new technology to assimilate the things and have to learn quickly now. So measure and lean and literate. So use the KPI and data-driven feedback to loop to measure the success and continuously adopt based on the real-time performance and insights. So these are all the things to be followed while implementing this smart facility in our system. So the conclusion is the smart facility of the future will be autonomous, predictive, and connected with AI, IoT, big data and big data at the core. This is the center point for the future in that whenever we go for the smart factories now. A successful transition requires a well-planned strategy, the right technology infrastructure and investment on people and culture. This is more important.
Thank you, Mr. Morgan. You had touched upon a very important, dimensions. Management vision alignment is very much mandatory to have this sort of initiative successful in the organization. And the other is we have to start with pilot projects instead of scaling it up entire organization. And digital skilling is utmost important. So very insightful things which you are doing already. So kudos to you and the entire team which you are doing in the organization. Okay,
Thank
over
you.
to Mr. Chinmay for your views on this particular aspect.
Thanks, Apoorv. So, firstly, just going back to the question, right? You talked about integration of technologies like AI, IoT, and big data. I would also say that it's an integration, but also prerequisite to one another, right? It starts with IoT. You have to have the sensors in place to collect the data. Once you have the data, obviously with the sensors, now you have the ability to collect data every second or whatever frequency, right? It's huge amount of data that keeps coming in. That's why the big data topic, and that's something that we as humans will not be able to decipher. We just have limited capacities for us to analyze it. And that's where the AI, the artificial intelligence comes in. While, of course, our intelligence drives it, it is required just to parallelly process it. So there is a link and a sequence in which this needs to go in terms of IoT, big data, and AI pieces coming together. And this is not anymore a future to be looking forward to. This is already happening, right? A lot of companies already are leveraging the sequence to kind of get a lot of benefits as well within their plants and in the product development cycles as well. A lot of the benefits, of course, were spoken about in terms of, let's say, predictive maintenance kind of scenarios, right? In order to be able to assess when the breakdowns are going to happen, looking at the patterns and probably stopping it during the downtime and fixing it so that you don't have production loss or safety issues coming in picture. Quality control, I think Mr. Jaivel spoke about vision-based systems as well. So there are multiple use cases that obviously come into play in terms of real-time monitoring as well as productivity and improvement aspects that come into play. But when we're talking about machines, I would also like to expand the scope to say that the machines is not only the actual production machines that you have. The machines actually are all the other machines within the plant, your AGVs, your pick place robots. It could be the entire ecosystem, right? Not just the core line that is there. And all of these have to talk to each other as well, because it's a synchronized operation within a plant. So if it's a line, of course, it is synchronized, but all the peripherals also have to put in place. And when I talk about synchronization, the entire supply chain comes into the picture as well. So how do you kind of leverage the data coming in from those aspects as well? Because let's say demand patterns, right? There is so much data that is coming through from other machines. And I'm not talking about just the smart machines in the plant. So all of those aspects need to be considered and come together. How do you kind of um, deployed for a successful implementation was the second part of the question. And that is where technologies like ours also come into play. At Dassault Systems, we basically are in the business of creating virtual twins of your physical plants, right? And when we talk about virtual twins, it is a little different from digital twins. And I'll touch upon this in the later part as well. But it's not just a physical replica of what your plant is doing. It's a behavioral replica, right? What can happen if A happens? What would the behavior be like? If B happens, what would the behavior be, right? So it's basically scenarios and what actually the reactions would be on the line, and you being able to test that real time for a lot of different what if scenarios before you're actually deploying it. We also talk about virtual commissioning. So you have your PLCs, your hardware in loop, software in loop, but when you're actually commissioning and deploying it, it does take time on the floor. Can you do that digitally ahead of time, validate it, and once you're doing it, the commissioning, the physical commissioning on the line, it is done first time, right? And in the shortest possible time. So there are different ways and means that digital technologies can be used to help set up your smart factory, to validate your smart factory before you're setting it up in reality as well. And as I said, some of these examples I've just given at a high level. Maybe as we go through Apoorv, I'll dwell a little more into those as well.
Sure, thank you, Mr. Chinmay. And again, you touched upon two important dimensions: data capturing on real-time basis. So that's the most important vital part of the entire smart factory, and synchronization of data in the entire supply chain, not only keeping it gate to gate. So that's again, virtual twin is again a very innovative thing which you have for scenario planning. So that's an interesting thing which industry should adopt, and that's how will and of course industry may be adopting some companies, and this will really help in the transformation journey further. Okay, so moving ahead quickly on the second dimension. So, what strategies do you recommend for overcoming resistance to change within organization when transitioning into a smart factory model? So, maybe Mr. Chinmay would like to hear from you this aspect first, and then we'll have a word, views from Mr. Jaival.
Sure, Apur. So I think some of it Mr. Jaival did touch upon. So the why is very important, right? As to why are we doing a smart factory? Obviously, it is uh, from a business KPI perspective to improve your throughput, to get more products out at a lower cost and in a more sustainable and a safe and manner as well, right? So that's the axes that you typically look for as to the why in the business context, and that has to be very clearly defined. You wouldn't want to start off on this kind of a project without having the why very clearly defined. Once that is defined and everyone buys into it and is clear as to why are we doing it and how does it help the company and subsequently my own job role as well, right, within the organization, especially on the production side, I would say in the current context or the discussion, that basically solves half of the challenge, right? Well, the buy-in is the most important part, and if everyone is convinced around the why and what's in it for me, I think that helps it going and reduce the resistance as well. The other part is, especially with digital technologies, what we've seen is there's a plus side and a minus side to it, right? So if you have um, people who've been doing in a certain way for, let's say, 10, 20 years, there's always going to be a resistance to change in the sense that we've been doing it this way, it's working well. Why are we trying to look at new things? Even after the why, there's still going to be certain things. But the flip side to it is there's a new younger workforce coming in, which has always been on the digital, at least for the last 20 years, the younger people who coming out of college are a lot more digitally savvy, right? And they look at it from the other lens to say, why are we doing it so manually, right? Why are we not using technologies to solve this? I think there has to also be a blend to kind of have these or a bridge to be done between these two, I would say, thought processes. What we look at is typically methods like shadowing, right, for digital technologies that we'll do it. You sit with us, let's do it together. And 3, 6 months down the line, you slowly take it over rather than saying that, hey, this is a digital technology. I showed you how it works. Now go figure it out. It doesn't work. These are complex systems, require certain time and patience for people to pick up as well. And that's something that we do to help overcome the resistance as well. It's not more an implementation, especially for us from a software perspective as well. I'm sure Mr. Jay will talk about the actual physical parts as well. So that's another thing. And we always look at also the change management part that Mr. Jayvel spoke about, right? Take it in smaller pieces. Don't try to say that I'll do the entire plant when in one go, right? It's just too scary a thing. Plant is a complex, huge thing. It's not just the line. You have utilities, you have civil structures, HVACs, everything in there, which makes it a lot more complicated. So take it piece by piece, maybe model an equipment, see the behaviors, extend that from there, right? That gives the confidence to the people as well as to how the technology is kind of coming in and helping me kind of change my traditional to a smart machine and then subsequently to a smart factory. So those are the steps I'm doing. How am I simulating it before I'm going there, right? So that would be another piece that I would say. And any of these projects, and especially technology projects, I think while typically earlier it used to be the CIO function, now you have the CDO function, which is a lot more broader. But unless the business is in there, and business doesn't have to own all the IT aspects of it, obviously, but business has to be there because IT and digital can only do so much. The actual on the line in the plant everyday issues is something that they live, they have to kind of go through. And unless that perspective is coming in, you can't necessarily bring that intelligence and make the factory smart subsequently, right? So you have to have that intelligence. It can't be an IT-driven project, at least from a digital perspective. So these are some thoughts that I had to share to kind of overcome the resistance and have everyone kind of participate in realizing a smart factory.
Great. Thank you, Mr. Chinmay. Why define why is most important and change management, of course. And Mr. Jayvel also touched upon this thing. Any quick comment, Mr. Jayvel, on this particular aspect? Although you had covered most of the thing, but would you like to add anything to this?
Thank you, Dhruva. And mostly that Mr. Chinmay has covered most of the points. Still, I have some points to cover on this. To overcome the resistance to change, one of the most critical challenges when the transition to a smart factory. So that always the resistance will be there. The resistance not come from this. So the units, for example, factories are working with unionized environment now. So people having that unionized environment, and automatically that there will be a job insecurity kind of things will be there. So a lot of resistance will be there. And again, that if the people having that cultures are more than 40, 50 years old culture, then people having the age, that the new technology adaptation of this will be adaptation, there will be fear will be there in the mind now. So there should be a very clear communication should be there on the purpose why we are creating this system for the company now. Why we are creating the smart facility for this, the purpose. The purpose to be defined properly to these employees. There should be removed. So for example, the purpose should having the highlights kind of the benefits like the safety is increasing, efficiency of the machine, the plant efficiency will go up, and competitiveness, so business competitiveness, and as well as the employees competitiveness, this will go up, and also the job enrichment. These are all the very good, important key aspects. Also, the benchmarking with this our competitor, that's more important. So the purpose to be defined clearly by the management. Why we are going for a change in that the smart factory kind of thing, that is more important. That has to reach that downline people. That's more important for that to success of this story now. So secondly, the employee involvement at the early stage, not at the last part of this. When we go for the change, then the employees to be involved and communicated in the properly in that manner, and convey that all the stakeholders in the part. So by in terms of planning and decision making level, you have to communicate properly, and create the cross-functional team to provide the feedback. Always the feedback is very important. Timely feedback and get the feedback from the people to implement. So all the things automatically will give the more success for the implementation. So third parties are mainly on the training and the skill that is more important. So the people doesn't have that skill to handle this type of technologies, So that continuous training program and tailor-made various programs for the customized solutions, customized programs to be handled, trained to the people for the various levels. So that is more important. Also, the technology has to be inculcated in that blood, the DNA of the system. That's more important. Focusing on the reskilling and not replacement. Replacement should not be there ever mind. So it is where reskilling and give the upgrading the skills that is more important. That gives a very good confidence to the people. That is more important. The mainly on the job security is very, very important. The address on job security and transparently have to communicate to the people that job is secured now. Because of this implementation, job will not be on threat. That is more important. And honestly, you have to change that, emphasize the job transformation and elimination of this that will give that successful implementation will be there now. The small and the pilot project. Again, one more time, I'm saying that is a pilot project is very, very important for the taking for the product in the bigger way. That's the successful implementation of the pilot projects that will give the confidence to the both management and as well as the employees and operators level. So that give that very quick settle down of these products on this one. And also that the risk will be less. If we take the pilot project, all the business pros and concerns will be evaluated, and all the things will be addressed and taken for the next level on the higher level projects. The change management is very, very important. The proper change management, the process to be adopted, and it will motivate people and resolve the concerns and promote the new vision to across that departments. That is more important for the successful implementation for the projects now. So then also that we should have that the proper communications on the mainly on the outgoing communications like town hall meetings, newsletters, dashboard communications, one-to-one meetings. These are all will give that confidence to this team and management and the employees of the company. That way that this will be successfully implemented, and the successful digital transformation required as much as focus on people and technology. That is more important. And by cultivating a collaborative culture and investing on the employee development and maintaining open communication, that's more again, communication is very important. Organizations can successfully reduce resistance and drive smoother transition to a smart factory.
Correct. Thank you. Thank you for all those insights which you had touched upon. What are the basic challenges you are facing in transitioning from traditional assembly to smart factory equipment? So maybe Mr. Chinmay, would you like to address this first and then go ahead?
Okay, so one of the things, obviously, the poll has a cost, and normally cost does factor top. But the integration part, right? I'll take it from a cue from that, the second point. And in terms of the digital technologies that we look at, we have a solution, what we call as virtual commissioning, right? So it is a subset of the virtual twin. So typically when we talk about virtual twin, what we're talking about is it could be a twin of the product or the manufacturing process or the entire plant, right? It really depends on what scope you're looking at. And the intent here is that you validate whatever validations you need to do in the virtual world. You do whatever iterations, what if simulations that you need to do in the virtual world, rather than having to spend time, money doing this physically, right? It is a cost, definitely a huge cost, and time is money as well. So you doing it physically is also a lot more time consuming. So the intent of the virtual twin is that. Now, again, within that, as I said, you have a virtual product, a virtual factory twin, you have a process twin, but we also have something called as the virtual commissioning. And this is where the machines come into picture as well, right? So if you have smart machines that you want to simulate their behavior, rather than doing it during the commissioning stage or the site acceptance test and later the factory acceptance test kind of things, rather than doing it there, can you do it virtually? And we have technologies today where you can model the equipment as one thing, but you can actually take the real controller that you have, or you can actually have a simulation of the controller as well. It really depends on how you want to do it. and use that controller and the controller logics that you have to drive the machine in the virtual world, so that you're validating the physical controller itself for its behavior and performance before you're deploying it on the line. And this is, I mean, to address the challenges of integration, right? I mean, we just one of the largest automotive companies in India, we're in a project, and this is exactly what is happening there even now for a newer plant, right? That you have a third-party vendor who's supposed to give you the controllers, the PLC logics, and there is a gap there, which is impacting obviously the overall line deployment and the go lives that have to happen on the physical line. And we're saying, hey, why are you spending so much time physically? Give it to us in parallel. Let me do it and be a lot more agile and faster about it, and so that you can have that. And obviously, it can't be done for the current plant. It's almost going live, but for the next plant, that's the kind of discussions that we're having, and that helps, right, to address the challenges that you would have. So in the traditional assembly line, what we would do is we would just make a 3D model and have the kinematics to simulate the behavior of the line, but it would still be at a constant speed. So if I were to say that the throughput is it would process 100 products or cars in a shift, you kind of set that station-wise time, it would do it. But here, what if this happened in the controller, or what if this check failed? So those are the kind of what ifs or probabilistic things that you're getting into picture to simulate. So it's not just fixed simulation, but it is with the realistic behaviors also coming in of the smart factories in the virtual world. So that's how we kind of try to address it from a software perspective, is what I would say.
Great, thank you, Mr. Chinmay. And those were pretty good insights, about those innovative solutions, which helps those challenges to address. Now, I'd like to hear from you, Mr. Jaiwal. What is the real-time challenges you faced in your organization and how you addressed?
Basically, that from the transition from traditional lines to the smart factory environment, this is a big jump from this normal one, since we are doing all the way from this conventional way of doing lot many things, and we are suddenly we are going for the smart factory. It is completely paradigm shift now. It involves a lot of significant challenges technically and also operationally and culturally. So these are all the major big steps to be seen in that kind of implementation. So just I'll take to some processes. How are the process? How is going to be the key points? How it is going to what kind of challenges we are going to face it, and what kind of solutions we are able kind of things. One is that legacy system integration. See, ours is very conventional base. Since our factory is around more than 52 years, we completed a years now. We are the business more than 5 decades now. So ours is very completely, it's a very old one. And the existing machines and softwares are outdated. That means in many spaces not available now. That is not been compatible with this modern IoT and AI solution systems now. So these are all the challenges we are facing in front of us now. So what kind of solution we can provide now? So one is that using of IoT in gateways or retrofit kits, very small aspects. What are the things can be smart functions can be implemented in that existing system, that is to be identified, and we have to put it that way now, and implement the middleware platforms to bridge the old and the new technology without full replacement. So that way that we can use the asset instead of going for the full investment and for the capital investment of intensive. Instead of existing asset can be replaced by using the middleware platforms, and it will be used for this. We can use that benefit of smart and as well as that old facility also now. That is one part. Second thing on this initial investment is very high. Of course, this is very important. And if you go for the complete new setup for the greenfield project, definitely we can go with a full-fledged way now. So this upfront cost of this hardware, software, and training and projects can be barriers. So these are all the things for this going forward for the new kind of setup. This is definitely it will help us now. So in our kind of existing setup, we have to take a very small pilot project, as I mentioned earlier also now. So we have to take its demo and make it get it of the based on that we have to try out and get that plus minus pros and cons. Then we have to go for the changing that one by one. We have to change it on this way. And third thing on this cyber security is very important. So more connected devices, more points for the vulnerability. No, so that's more important. If we are exposing to this for the cyber, always we are finding a lot of challenges in the cyber security. No, so a lot of confidential data are in that for design, for example, design drawings. And so many complicated things are given the process parameters, machine parameters, so many things are there in that current system. No, if you go for this kind of things, it will be exposed to the world and it will get everything will be taken at somebody. So that is a very good, that will one day it will become a big issue. That is very important. That has to be taken care properly. No. So there'll be one more point on this workforce resistance and skill gap. Again, this human resources is very challenging, and the employees must be resist for the taking a challenge. No, so definitely the lack of skill, they have that fairness to we may not have the skill to operate that CNC machine kind of things. We have to give the confidence as management. You have to give the confidence. We have to identify the people, and we have to give that proper training to them and give the confidence. Put them in the specific machines, and after that they have to give that their self confidence will be there, and automatically then one person, 2%, 3%, maybe 10%, one place, two place, like that we have to develop it as a mass then. And downtime transition, so this is more important. Upgrading the system is very important, but the production will disturb now. That impacting this our supply chain and the customer and all the connecting element will be disturbed now. For that, we need to have the proper plan how to implement. It has to be put it in that phased manner. Implementation is very important, and so we have to put that redundancy is very important. Where the system is going for the down, what is to be done for that? For the backup plans to be plan A, plan B to be maintained. We have to make while going for the implementation now. Again, that change management organization culture is again coming as whenever going for the change, that is more important. The supplier ecosystem. See, when we go for a change as a industry, we can put investments, we can make a change, but we have to take it something from supplier now. That the entire chain to be taken care. So that way that the smart factory relies on the real-time coordination across the supply chain, from the starting from this supplier to our end product to the customer. That entire thing to be taken care, and we need to call supplier meeting and educate them and give the importance to this what kind of things we are doing here now, how it has been helping for us, and as well as for the what is the requirement for from your end. So that has to be properly educated to suppliers, and we have to give the confidence to them. If any investment done by the suppliers, then we have to give the confidence to them. So that will be a collaborative suppliers and shared digital platform. So whatever platform we are using, that has to be shared to our suppliers. So then they can use it of this same facility. Then they also build the things, and that way it will be definitely helpful for both of us, and will win-win situation for both of us now. Use the blockchain or maybe supply chain visibility tools to transparency and coordinations now. So finally, the conclusion here, this a shift to smart factory as a complex but manageable with the strategic phase and people first approach. So people are important, very important. That's if they give the confidence to the people, then automatically this will be success factor will be more no. Companies that succeed often threat is on the journey of the continuous improvement, not on the just one-time upgradation. No. So this is from my end.
Great, thank you, Mr. Jayawal. And very important dimension which you just narrated in the last moment is that extending it to the entire supply chain. Until unless your suppliers would be enhanced and upgraded, whatever digital you are doing, your organization would not suffice. So that's a great insight. Okay, so I'll have a second. I think we had covered, good examples from your end, Mr. Jayawal, that implementing smart factories, how it has helped in improving the productivity, product quality. Do you want to quickly touch anything else additional? What how it helps in enhancing your productivity?
Yes, I have some points to cover here. No, some
Yes.
of the specific examples of how implementations. Say the implementation is something different. We're talking something different. No, smart factory here. I'm putting in the 4 parameters. So one is the smart operation front, a control front, safety front, and connectivity front. So what is smart? The smart operation. What kind of operations we are giving to this machines now and operations now? Eliminate that manual interventions and enabling the machine to understand and perform process by reading a barcode labels. For example, if you read the barcode labels, simple barcode, it gives the entire details of it. It may be a process parameter, it may be a machine operation, everything will be there. So one test, then it will be all the things will be given to the machine, and machine start working from that. A small controls. So this is very, very important for the machines now. So monitoring and the machine and the process parameters automatically adjust that within the specific times limits to produce the defect-free quality product. That's more important. The machine has to take the feedback from the system and automatically adjust that parameters and give that right product without any defects. No, that is more important. And anything goes beyond, it will raise that alarm and stop the operations. So it will be either production, either damage will not be happen for this product material, and as well as the damage will not happen for the machines. No, it will be protecting for this both things. No, it will be both will be safe. No. And the third thing is nowadays that everyone talking about the safety is very, very critical, utmost priority for this. Since we are building the machinery, since we are being the machine builder, and we have supplies a lot of tire curing process for the domestic as well as international supplies. And we build this all the features in our machines. And mostly that whenever we go for this international customer will see the lot of safety features in our machines now. So that is safety is very, very critical for the operations now. What may come, what may go, but safety, no compromise on the safety parameters in the machines now. So it is taking care of this. You have to find out all the safety zones in the machines as well as in the smart factory means you have to find out the entire factory. You have to identify that what are the safety features, safety zones. We need to address all the zones too for the safer working. Smart connectivity is very, very important now. So, for example, we supply the machines to US, Europe, so many countries now. So sometimes the breakdowns happening there now. So the connectivity is very important by through the SCADA systems and or Ethernet kind of things. We do the troubleshooting from our end now. We do the troubleshooting, all the things. We take the data from them. We ask them customer to give the permission to interact with the machines and to take the data and to find out the faults and they will activate the things. So that way that the connectivity, smart connectivity is very, very important for this state of for the implemented stage now. So that what are the technology, for example, if you see the things, what are the technology involved here? So again, what we discussed in the top, but one is the IIoT, artificial intelligence, machine learning, and automated guidance. Sometimes AGB also very important. For example, AGB nowadays, many of them are using for the stores now, retrieving the stores and the putting the materials on the racks and this thing. Also, that's one of the company in the battery company I visited recently that they're using that AGV for this all kind of material movements as well as the production items. Now, automatically that batteries will be carried to this one place to other place without any manual intervention. It is a 24/7 technology now. So the real-time data analysis is there now. So what benefit we are getting for this now? So one is the improve that the efficiencies in terms of the manual efficiency as well as the machine efficiency. Overall, it's the plant efficiencies comes place now. So improvement on the quality front. So we get the right product, defect-free products, and continuous monitoring will help us to reduce the defects in the system. Also, we get that very good product from this the machines and the product from the factory now. That way that our delivery performance, also the quality performance will be in the high order now. Also that the productivity improvements on the multifold productivity improvement, of course, it will be there for these benefits and it will give that good top line and as well as the good bottom line for the management now.
Great, thank you. And very relevant dimension, smart safety. So that is utmost important nowadays. So everybody is looking for that thing. Great. So now before I would address two more points with Mr. Chinmay, Julita, can we have a quick another poll?
Of course. So here is our second poll. What aspect of smart machine integration do you believe will have the greatest impact on the future of manufacturing? Increased operational efficiency, enhanced product quality and consistency, supply chain optimization, or sustainability and energy savings? Again, we're leaving this poll open for 1 minute. So if you can kindly submit your vote, we will discuss the results in 30 seconds. Thank you. Leaving it for 10 more seconds if you'd like to submit your vote if you haven't yet. And closing our poll. So from the results we've gotten, we have a majority of sustainability and energy savings. Back to you, Apoorv.
Thank you. And that's the very important dimension again, because it all revolves around having a sustainable business. So that's how the industry is also expecting to contribute. Okay, I'll address these last 2 points, Mr. Chinmay, with you. Although you had covered, so if you can quickly touch upon what innovative digital solution are you developing to support this transition to smart factory, and if you can also throw light on how to ensure the digital solution for smart factories are scalable and adaptable to different manufacturing environment and industry. So if you can touch upon on those two. Yeah.
Sure, Apoorv. So, firstly, at Dassault Systems, while I've spoken about virtual twins as well, I'll take a step back. About a decade back, what we started doing was developing what we call the 3D experience platform, or we released the 3D experience platform. And what that basically does is, firstly, enables a collaborative environment across the enterprise, right? Not just the manufacturing folks. Earlier, I was talking about a lot of other actors that may come into picture as well in your supply chain. I think Mr. Jaivel spoke about it's not just you, it's the entire supply chain. So how do you get your suppliers on board? How do you get your internal teams? It could be finance, it could be legal, it could be regulatory, it could be safety. There are different aspects to any change that you do that need to be considered. And having all of those people on a single environment collaborating with a common goal of achieving a smart factory to deliver on the specific KPIs that you have. Could be sustainability KPIs. I was actually expecting it to be operational efficiencies as well, but yeah, I mean, everyone has a view around that, and both of them are important aspects. So having a collaborative environment so that you're a lot more agile in terms of making decisions, informed decisions based on data in a collaborative environment is key. So that is something that we definitely do. I spoke about virtual twins, but within virtual twins as well, we traditionally used to have the digital manufacturing aspects and factory floor simulations, as we used to call it, and making those smarter. By bringing in the smart devices inputs as well is an important aspects that we've enabled within our portfolio. The second portion to that question, right? And I'm not getting into supply chain and other aspects for the paucity of time at this point of time. But just the AI ML aspect, while it was an independent development when it started, but obviously it is getting infused in all aspects of our platform as well, be it design, be it manufacturing, be it simulation, the FEA, simulation. So there's multiple use cases where actually AI can help augment or do iterative what if scenarios by itself in order to kind of give you the best solutions that you need to implement. And just taking it a step further as to how do you go ahead and make it scalable and implementable to different industries as well. So our solutions cater to 12 different industry verticals. That's what we do. And what we've done is basically based on specific industries, we've built accelerators as well, right? So what we call as value path and business process mappings. So while the same solution can work for different industry, you have to contextualize it for that industry. So we have industry experts coming from the industry that have helped us actually build value paths in terms of what typical challenges you would face, how you would go ahead and address them, what kind of scenarios would you replace. So we kind of have packaged all of that for all of these 12 industries. And whenever we actually go and have those discussions, we have industry experts also that join us beyond a certain time to have those, the SMEs coming in actually help talk the language. Like if I were to say, yeah, I come from the mechanical and manufacturing side, but if I have to go to a pharma, it's a complete, of course, pharma also has manufacturing, but I don't understand the pharma manufacturing process because it's a completely different process slash batch based versus a discrete manufacturing, right? So the same solution, how does it adapt, is where the SMEs come into play and has helped us adapt, but also have us help us have those conversations with those companies. But overall, the architecture itself, from an IT perspective, if I were to say, the concept of a platform is you have a single base, but then it is modular on top, right? You can plug and play different solutions on top based on what your requirements are. So it really depends on Again, we have, as I said, modeling, simulation, manufacturing, process planning, supply chain, data analytics, all of those different solutions. No, not everyone would need everything. You could have other solutions in your ecosystem. We typically have to coexist with ERP. So you have to have these integrations. I think Mr. Jayvel spoke about this also in one sub point to say integration. I have legacy. How do I integrate with data? It could be from machines, but it could be from systems as well, right? That also becomes a challenge sometimes. And having cloud-based solutions, especially, um, I would say it really can go for larger enterprises as well. For smaller ones, especially what we talked about, start small, agile, do a quick proto. The cloud technologies definitely help to have a quick deployment, more standardized, but at least you get a flavor of what you can do with the solution and what benefit you would be getting, and then kind of extending it from there. So those aspects are there within our platform and portfolio as well. So just a few comments on that, yeah. And just one last comment on an example I just wanted to share in the north of India with the white goods manufacturer, right? All of this that we've spoken about is something that they have actually gone through in terms of virtual twin. They had certain units per hour throughput. The intent is using smart technologies, can I improve that throughput? Automate some of the stations, but wherever we're doing the manual processes, have safety as a very important aspect. So how do you bring ergonomics and how do you get smart machines, or the current machine, if it were to become a smart machine, what is that automation you would do on the machine? How would it help improve the throughput? What is the subsequent station impacts in terms of manual processes, and are those safe, right? So all of this is simulated at an entire plant level, which then they have gone ahead and rolled out onto the actual lines, right? So this is not something that we're speaking as a future. Again, I would say this is something that is already happening as an example. Just wanted to share that as well.
Great, great. Thank you so much. And we really, got the flavor kind of solution and innovative solution you have, and how you touched upon that it can be with cloud computing, it can be easily, scalable across. So that's very insightful. Great. Thank you so much, Mr. Chinmay. Uh, can we have any questions now as we are in the last few minutes? So if anybody, Leta, any questions from LinkedIn, or anybody in the audience, would you like to have some question?
No questions from LinkedIn, but please feel free to submit your question in the Q&A feature, or you can send us a chat message and we will happily answer them.
Yeah, so maybe if no more questions coming in, we'll just see. Yes. Okay, so meanwhile, if somebody poses a question, maybe a concluding remarks from both of you would help to close this. So, Mr. Morgan, over to you.
Yeah, this is the smart factory and the smart manufacturing. This all required a lot of technology involvement, and it's kind of a high level platform. So what we are currently talking about on the industry 4.0, it is talk about on the entire process, and which is enabled with a lot of sensors and IoT concepts and AI, all the AI ML, and also that digital twin technology. These are the higher end platforms we are using for this kind of this thing, and this will automatically, this definitely will improve the productivity, also that it improve that the quality of this product and the consistency, and give that lot of reliability on the machine, and the predictive maintenance kind of things, and it will avoid the breakdowns and the surprises in that processes. No, so that way the smart factories are coming up in a lot many things, and smart machines are coming very well. So mainly on the smart, what we built in the system, the companies for our customers, we build the smart machines which talks to the customer operator. So the machine has to tell us, I have the problem in my heart. Like that, the machine has to tells the problem in the electrical circuit, as well as pneumatic circuits, and the problem is somewhere in the hydraulic system. So that way, put that lot of sensors in that our equipments, and give that lot of data to the HMI. So the HMI give the pop-up message to this operator, as well as a lot of escalations also we are happening in that factory manager. For example, machine breakdown for half an hour, there will be a level for one level escalation. Machine level breakdown for second 1 hour means it will go to the next level escalation. Like that, the lot of interface data will be there automatically. That interface and as well as safety features will be there in the machine. and it will automatically give that entire comfort for the operator as well as the management as well as that for the production and environment now. So that way that give that lot of best practices also be placed in the smart factories and the smart machines now.
Thank you, Mr. Jewel. Over to you.
This again, it's again a technology intensive area. No? This technology intensive area. That's only the final statement. Yeah.
Right. Yes, over to you, Mr. Chinmay.
Yeah, I mean, just firstly, thanks, Apoorv, for moderating this and organizing this. I think the two perspectives, right, from Mr. Jaivel, who actually makes the smart machines and kind of supplies it to other customers as well, and our perspective from a technology or a simulation technology perspective, wherein we help companies.
Each other.
Yeah, we help each other in a way to
Each
kind
other.
of
Yeah, each other.
realize the goal. Realize the
Yes,
goal. I
yes.
think those two
Yes.
perspectives coming together was very interesting to me as well. Yeah, and I think the parting comment is yes, all of this is reality, and I'm sure everyone on the call that are there are working on some aspects of it, and any which ways that we can help for sure. Please feel free to reach out, and we'll be happy to have a conversation.
Great. Thank you, Mr. Chinmay and Mr. Jaivel, for your concluding remarks and your time and effort here. Quick summarization from my end. Like we had touched upon different aspects, different dimension, and the participant also touched upon sustainability. So it is very imperative that if you would like to become a sustainable organization, you definitely have to take care of your processes. And then when the processes are quite 70 to 80% watertight, then and then only it is advisable to go for a digital solution. Otherwise, it is garbage in and garbage out. So you have to first take care of process, back it up with digital solutions to make it more robust. And hence you are making each and every process of your organization sustainable and entire organization sustainable. So that's concluding remarks from my end. So thank you very much, everyone on the call with us. And thank you, Mr. Chinmay and Mr. Jaivel, for your time and effort here.